So I'm going to keep this pretty informal. I think that the just general question here for both the panel and the folks on what is the, how do we expect these various technologies to kind of evolve over the future here, and how do we expect to, how does that impact how we use them? So I think everybody's kind of made a fairly strong case for their different technologies. So first of all, I certainly open it up to questions from the audience. So if you'd like to just, if you got something you'd like to ask the panel, please allow it right now. I guess maybe we'll start. Maybe I'll just start with the flash. So the flash, you guys are a little aggressive. I mean, Rob, you pretty much flat out said you could do a large archive and so is that actually what you're doing? Was that specific use case, that specific set of parameters?
It certainly is specific to every customer. I will not say, I'm not looking for world domination of flash, right? Not going there. Because, again, I started in the tape industry at Storage Tech, worked in there for over a decade. So you know the story about tape. But on a customer-by-customer basis, there is a strong TCO argument for, if not all flash, then a majority of flash, even for cold storage. Now, we all know that does not hold true for every customer, no question about it. Again, if that was true, we wouldn't have the rotating disk 60 years later, and we still have the rotating disk, and it's still useful, right? But my argument is the use cases for this type, based on the density curves, based on the TCO, may be shrinking, maybe faster than some people expect. That's all. I mean, again, there is no one dominant technology. If it was, everybody would be in it, and it would be obvious, but it's not. Use cases are all different.
So I wanted to add to that because I don't know how many people were here last year, but a guy from Saratoga Speed asked me if I was making the comment that flash would replace hard drive and hard drives would replace tape. And I actually made a statement during last year's MSST that said, no, I believe that flash is actually better positioned to replace tape. We haven't even put power management capabilities into our flash devices yet. And even without power management, we're sub-watt per device if there's no I/O happening to it. When you start looking at sleeping flash at the density, when you break apart away from the 2.5-inch form factor, you're rivaling potentially the density of the tape cartridges she's talking about with potentially zero power use and almost immediate within milliseconds wake and response time. Now, it'll never get to the cost point of tape, but the architecture above that is where the interest level happens. And that's why, as my colleague here says, Ceph and technologies related to erasure coding and spreading the resilience across the devices, so you're not doing replication, is more of interest to us. And when you do the failure calculation, you could go extremely wide instead of going to the 8+2 traditional RAID or whatever. I mentioned 26,2. You could even go wider than that and get to equal to the tape or hard drive failure rates, but we'd rather stay above it.
Go ahead, April.
Yeah, I think it's very interesting the capacity points that Flash are predicting. That should be very exciting for people who need fast random access. But you do have to watch power, and I'm most concerned about looking at reliability and the efforts, all the extra eraser coding you have to put on top. Tape is order of magnitudes inherently more stable, and we don't have to add all those levels. So you really have to start looking at your data protection schemes and figure out how much you should keep on flash and how much you maybe want to store on a secondary technology for data reliability.
Just again, I don't want to discuss this. This will become a much interesting discussion, but I agree that flash will not, for at least 5 years or more, get to the cost point of tape. And to keep the reliability and accessibility and everything else of flash, yes, you need to power it on once in a while, every 2 months, just so that internal scrubbing happens. But it's the same thing as retentioning tape and a lot of the other things. It's going to be an interesting economic play when you start putting power management into flash, the density levels, and then the use cases. As I stated earlier, there's no way flash will ever manufacture the amount of capacity that tape and hard drives can have. And it's a very expensive proposition to get in. But where we see high value today and the margins that we need, or actually we like, we're hitting those targets. We're not taking areas where we know we could do it, but it's not worthwhile, especially with the limited capacity we could make.
Go ahead. Yeah.
You touched on the question I was about to ask, which is what is the lifetime of data on unpowered flash? I thought it was only a year or two, and that seems unsuitable for cold storage.
Well, there's no question, and there's a lot of scientific literature on this, that unpowered NAND devices have a finite retention time, right? It's actually highly dependent on temperature, believe it or not. The environment you store it in is very key. Now, we can design, and there is some correlation between the inherent speed of the devices and the inherent retention. I don't want to get into that. But let's put it this way. There is a standardized method to evaluate this. And a very typical measurement is, 1 year at 35 degrees Celsius. That's a very typical measurement. Now, you go cooler than that, and the lifetime extends way, way out. So, I don't recommend you take your SSDs and put them in the freezer, but you could think about doing that, actually. That was actually a wonderful way to fix your hard drives back in the day. Still works, actually. Bonk, put them in the freezer. But anyway, you have to be careful of that. There's no question about it. But as my colleague said, occasional power is a very simple thing to do. I already know customers that are doing this. They're managing their own, right? It's not difficult to do, but that is a factor when you think about overall architecture. At some point, you're going to have to apply power to this. Or the other thing is, now we could make NAND devices, either SSD or non-SSD form factors, basically take any retention value that you would like. Same way with Uber, right? Not the car people, but uncorrected bit errors, right? I could build you a device at 10 to the minus 27th. Easy, right? Can you pay for it? That becomes the question.
So I think there's a place for each one of these technologies, but I'd like the panel to address a question I think that's been overlooked, which is the evolution of all these different technologies, improving densities, lowering cost. But as someone pointed out, I think it was Rob, the bandwidth issue. So we have a lot more mobile devices. We have cell phones, and everyone has storage on their phones, and eventually everyone will have a car that'll probably have an IP address. But the bandwidth isn't improving at the rates of the other technologies. So that's going to affect which one of these technologies might become more prevalent in certain areas and how the entire architecture evolves. So I'd like to hear what the thoughts might be about that.
Okay.
So when you looked at my presentation, what it really impacts the bandwidth of a lot of these devices is actually how you connect it to the rest of the world. And the WAN bandwidth is still limited. The data center bandwidth is going up aggressively. You're going from 10 to 25 with the transceiver change. You're going from 40 to 100. You're going from 100 to much higher, 400. And as photonics is just around the corner with all these different capabilities, you're able to feed higher and faster capabilities. And that's and Flash is following that trend. In fact, it's enabling Flash to be more effectively used. But that doesn't mean that all use cases require that level of bandwidth. When you start looking at things that are archived or seldom accessed, when you move things through data life management or HSM or whatever you want to call it nowadays, ILM, you see the access patterns, and then you model your infrastructure for that, and that's where the other lower cost technologies come in. because at that point, when something is untouched for weeks and you only touch small aspects of it, you don't need 100 gigabit lines. You need 10 gigabits or even a gigabit. And so each technology is actually plateaued by its cost to the customer. And then customers are trying to play this game of effectively putting the correct pricing, bandwidth, and capabilities in each of those tiers. And what's blurring the lines right now is the fact that networking is aggressively growing. Flash is aggressively growing, and the question is where does disk and tape reside?
So maybe 2 years ago, we published a blog post with some analysis on bandwidth increase and density increase on storage in the home. So this is not data center connectivity, but this is what you and I at home get access to from a bandwidth perspective, and those curves are not heading down at the same rate. So densities of drives are certainly increasing faster than the average person's home network capability. There are exceptions. If you have Google Fiber, fantastic, congratulations, but you're an anomaly. Right? And one of the points about whichever of these technologies you're using on the back end, the question is, how are you spreading the data and what data is getting accessed by what type of application or user? So when you're connecting with your mobile phone, you don't really care whether Apple is using tape drives or flash on the back end. What you care is that your phone gives you access to the things you want. Whether they're spreading that out on 57 different servers, 500 tapes of which one of those tapes is always online, or flash, they can all be made to work. It's just a function of kind of the amount of infrastructure required, the cost required, the amount of stuff you want to keep live, et cetera. So it's kind of application dependent, but these things can be architected correctly with any probably of the technologies, as long as you're willing to do the right thing on the back end.
There was an announcement last week that the number of broadband-based connections in North America has gone down for the first time ever, because people are using more mobile technology than they are, whether that's broadband, Comcast into your house, or DSL subscriber loop. So that's going to impact your model as well.
Yep.
Right? So you'll have to have a mobile device that does more computation and allows you to sort out what data do I push up to the cloud, because I can't be pushing up everything.
Yeah. All right, April.
I just wanted to add one thing in terms of trends with bandwidth and just infrastructure. From the tape side, we have been getting a lot of complaints because we still are on fiber channel. So I do believe in the coming years you're going to see tape offer some new connectivity options, trying to make it more common with the rest of the data center infrastructure. So I think that will be a change that we'll see coming as well.
I think I have a question for Gleb, and maybe moving into just this broader, as somebody like you makes decisions about, okay, will you kind of continue to ride where disks are going? This is actually one of Dave's slides, which he wasn't able to show, but it just shows, okay, if we can get to HAMR, then they start riding another sort of curve, and this happens, right? These aren't typically linear improvements over a period of it. There's often, I think, disks in the late 90s. It was I forget the name of the technology. Yeah, GMR. So GMR. Yeah. So and right now you guys are the Flash boys are getting the 3D pump right now. But then you're going to start. So it's almost like a horse race. So it goes back and forth. So anyway, back to you, Gleb. Do you how do you guys think? Do you guys think about this 2 to 3 years down the line? Do you have to start thinking about maybe you would make a switch, or what's your long-term, thinking about this?
Yeah, so we look at it from what fundamental technology can we use that's affordable and has the characteristics that we need that we can architect around. So we 9-10 years ago when we started the company, we said, we might be a few years away from where Flash will make sense in our environment. we're sitting here 9 years later saying we might be a few years away from where flash might make sense in our environment. And we want it to make sense in our environment, right? Like it would be great for us, not have, potentially lower power, potentially more dense in the space, potentially higher reliability. The problem at this point with flash is it's still 10 to 15x the upfront acquisition price. So from that perspective, when we do the math on it, there is no operational savings that can justify that level of change. I was talking just earlier today about that. I actually think this year for us was an exciting moment for Flash, which is it's the first year that Flash overtook drives in terms of density of a drive, right? With the announcement of the 16 terabyte SSD, it was the first time where it's still way, way, way too expensive. But at least there's the argument that it's more dense. So if all you're going for is pure density, that there's a technology there. Now it's unaffordable for the purposes, but at least one of the two metrics has been hit. So that is what we're looking at overall. We've looked at tape probably half a dozen times, and it has never made sense in our type of environment. When you have multi-tenant, large-scale bandwidth in, bandwidth out type of environment, I do hope and believe that that there will be a future for Flash. Drives continue to seem to be a clear path for the next few years. SMR is interesting. It would be better for pure archival, which we don't have as a pure use case, right? So people do read data, they do delete data. So it's imperfect, but it's not bad. I'm excited for Hammer for whenever it actually becomes available on the market. So we just kind of look at what are these different things and what's plausible to use for the use cases.
Okay. Let's see. I'm looking out at some users in the Gary, would you be able to comment on kind of where what you're thinking and where DOE's thinking on the usage of these various media? I'll let you. I can bring you. Okay.
Sure, I can try. We have a bandwidth problem pretty badly because of the size of the objects that we deal with, these petabyte and up size objects. And so all the models we've done sort of take tape out of the equation because of the sheer bandwidths needed. You'd have to have thousands of tape drives to stripe to get the bandwidths we need. So we see tape as moving down one tier in DOE, I think, in that you put things out there that are small enough that you could actually get them there, because getting a petabyte out there is just not, in any reasonable amount of time is just not reasonable to think about. At least the parallelism required. So that's actually why Campaign came about, right? Is we had these multi-terabyte per second parallel file systems, and we couldn't go all the way down to tens of gigabyte per second tape systems. We had to put something in the middle there. This was just a bridge too far. But I don't think the tape will go away because we still have stuff that we can't lose ever, because you can't even reproduce the data anymore because you can't test in Nevada anymore, right? So, that stuff is so precious, it doesn't matter. You have to put it on tape in multiple places even. On the other hand, I think what we see is by 2020 for our big machines, we're very likely not to see a scratch file system made out of disk. I mean, we think 3D NAND is going to do what you said it's going to do, and we think that the high-end disk market is very likely going to be the first to tip over. And that's what we use for our parallel file systems. So it seems very likely that the next machine we buy in 2020 won't have any spinning disks. It'll be a 30 or 40 or 50 petabyte inside the machine running at 10 or 20 terabytes a second kind of thing. And then we probably would go directly from there to SMR or Hammer or whatever's available at the time. And that's about as far out as we can see. I don't know if, maybe in 10 years something would change, but we're guessing, and we guessed this a couple of years ago, that the next machine we bought in 2020 would have no DIMMs. It would be all on package DRAM of some kind. We guessed that we would have no spinning parallel file system, that it would be flash or something like that. We guessed that we would probably have no PMR or anything. It would all be SMR or beyond for our campaign level. And then we've guessed a while back that we would have to go relegate tape to some really, really small set of things that aren't bandwidth based. So I think that's our 5-year plan.
And then I was going to maybe have Randy Olinger from United Health Group. Could you kind of, it's a very large enterprise, so what's kind of been the thinking there in terms of where the various media play?
Well, tape is going to be relegated to a much narrower use case. That's what it really comes down to. It's going to leave the backup to what'll probably be the spinning disk drives, and it'll go toward the extremely long-term, extremely cold storage. That's just calling it like I see it. And it won't necessarily be a cost play. It's going to be a pain in the ass play because tape's still hard to use. So we've been kind of moving down that path. We've tried a lot of different technologies over the years. They've been evolving, and it's kind of at the point now just straight old disk drives works pretty good, except for the really long-term storage. And on the flash side, I really think that what's interesting to see the InfiniFlash, which is kind of just no features. Here's a bunch of cheap flash. I think that's the future, and the all-flash arrays with all the fancy deduplication and compression and all that. Yeah, they'll probably have a place, but their whole reason for existence is to make flash as cheap as disk, and if flash gets as cheap as disk, that's maybe not going to be as useful of a technology. So, yeah, I just think, and it seems pretty clear that middle range of storage performance is gone, if not going away. I mean, just everything that needs any kind of performance will just go to straight flash.
Well, I agree. It does feel like tape's use cases have gotten smaller, and it really does apply for that very long-term archive situation. But that's not to say that the growth isn't there, because we're actually seeing more and more data heading into the cold archive.
I should have mentioned that. It's a
area.
narrower
so
niche.
It's going to keep tape very, very healthy for an
and
industry.
that denominator is getting bigger, because so many different types of imaging and scientific analysis, the humongous files. That's why I say it'll be there. There's plenty of growth there.
Yeah, it is interesting to see that. If you, again, I'm not a marketing person. Marketing persons like to do pyramids, right? So if you envision that, the whole pyramid is expanding. Every 3, 4, 5, pick a number of layers, it's all expanding, no question about it. But the use cases are changing over time, as you well said. The other interesting thing about flash is, for kind of on the high performance end, not necessarily the cold storage. And this gets to overall machine design too. Many of you are concerned, and rightly so, about that. It is interesting with very, very fast, media and devices made of that media that can literally respond in less time it takes the kernel to service an interrupt. What does that tell you? Right? That tells you we should return to 50 years ago and pull. We shouldn't interrupt at all, because interrupt is a waste of time now with these very, very fast. If I can respond in 2 microseconds, which if you read the literature, a lot of people, if there is such a thing as an average interrupt time, it's 2 microseconds inside a Linux kernel on a garden variety CPU. And if I'm under that, I shouldn't interrupt at all. So it's going to change system design a lot. And then persistent memory is going to change system design a lot with that. And this is, a little bit outside of the quote-unquote storage domain, but it does affect how we consume systems, how developers write code, how, folks like you at United use these systems and what they actually do, because the whole idea is to try to make it as efficient as possible, right? Pay the right price for the right level of computation, for the right level of storage, that sort of thing. That equation is going to change pretty hard here in the next 5 years. It's going to be really interesting to see.
I'd like to add to what he just said, because I believe that once you get the persistent memory coming in, and again, this Crosspoint, this ReRAM, there's a bunch of, actually there's only 2 players at the moment. When you start seeing that, what you're going to see is flash local to servers are probably going to take a shift. There's going to be a bunch that will still be there because you need the storage local, and a lot of it's just to fill the memory, because you can't get faster than a PCIe bus to fill the memory. Even with NVMe over Fabric and so on, it's still constrained in local. And that's when you're looking at things like a 4 and 8 terabyte MicroStrategy cubes or things of that nature. You want to fill it in a shorter period of time. But then you're going to see the shift of flash being used as memory expansion to go to persistent memory, and then local memory or local storage for filling memory. And then the rest of flash is all going to be throughput-related flash for filling the bandwidth pipe on the network, and it's going to try to rival the cost of a similar infrastructure disk model today, but with a different architecture. I think that's the transition that's happening today. It's going to take about 18 months to happen, but in the next 2 years, I think there's going to be a very interesting play on these so-called data lakes of flash feeding in-memory analytics and in-memory database type things.
Yeah, and let me step out of my neutral kind of panel chair thing for just a second and make a pitch for tape. So I think, obviously tape, the operational complexity has been an issue. I think backup was never a great application. At some level, backup wasn't even a particularly great application for it. But I think we have a couple of very large customers. Oracle has Google uses it for Gmail for archiving. I never delete any email, so that's probably a good idea because I'm not going to look at anything. But part of it is if you get to cloud scale, then operationally you can have specialist groups that can deal with it and scale with it. And I think the other thing is I actually just joined Oracle, was at the large tape users group meeting, and as April's pointing out, the interfaces are going to change. I don't think we've quite announced that, but they're going to get cheaper. And I think the other thing is there's been some improvements on, a big issue with tape was migration. So it just, as Gary's pointing out, there's bandwidth limitations. If you have to do migrations at a system level rather than at a media level, it can be challenging. So anyway, I think there's some improvements, and we'll kind of see these use cases. I think the one thing it does have, again, being less neutral, is just that the roadmap is pretty straightforward. And I think with disk, once they get hammered, they'll probably start, they'll start pulling ahead of you guys again, and then you guys will start slowing down as you get to the limits of 3D, and life will still be interesting. Okay, a couple more questions.
I've got a couple questions. So first one, we hear a lot about the hyper-converged computing market. Interested in hearing how you're seeing demand, especially with Micron and SanDisk. What type of demand and increase in that demand are you seeing for flash server resident? Because that's a classic example of being server resident, is put all of your kind of enterprise workloads in a hyper-converged distributed file system with no storage array at all, no centralized network storage at all. So what are you guys seeing, and where do you project that market to be? Because that's a little bit different than, for instance, what you were just talking about with disaggregated, and then every tier being totally separate and scaled independently. So what are you seeing in the market?
Yeah, you're exactly right. This is, every coin has two sides, right? So hyperconverged, and we see a lot of activity, certainly from my company, and I'll let others speak for themselves, around that. I mean, and you see all the large enterprise storage vendors and the OS and hypervisors alike moving in this direction if they're not already there. I mean, I was just down at, in Vegas at EMC World, big, hyper-converged announcements. So many vendors are going this route. And, some virtualized, some not, but mostly virtualized, certainly server-based, and then scale out, software-defined storage, if you like, software-defined networking. Use the term of choice. And that's a market, ironically, that the smaller, at least from my experience, the smaller enterprises like a lot, because they don't want to go to the disaggregated model. Right now, on the other hand, the largest of the large, the hyperscales, are begging the industry for better disaggregated solutions, because they have seen the limits of what you can, do an OCP server, pick your kind, and there's only so much you can cram into this box, right? So if I need to directly address half a petabyte of, non-volatile memory using memory semantics, I can't put it all in one server, so I have to disaggregate. And again, a number of the hyperscales are going in that direction, but hyperconverged is quite popular in kind of the small to medium commercial market, and there's tens of thousands of businesses that want to consume that. So that's getting quite popular now. There's no question about it. There's entire companies that have sprung up in the last 5 years just to service that market.
So I'll give our opinion on that because it pretty much mirrors what Micron says. In the hyperconverged market, we have part of SanDisk is the enterprise storage market, and we have a large engagement with a lot of those people. I mean, we have a much stronger engagement with the hyperscalers, but we're still selling all over the place for local server-based and our own software stack. We have a FlashSoft caching software for VMware. We have partnerships with a bunch of people. In fact, early this year, we announced a partnership with Spectrum Scale, and that actually generated a lot of interest across the board. And if you look at where IBM is trying to take Spectrum Scale, hyperconverged is one of those areas. So when you start looking at the interest of flash, whether it's a small amount of flash in a server or even larger amount of flash, 8, 16 terabytes within a server in a hyperconverged model, it still makes sense. The question is more, how much data do you need for the throughput pipe that you have? And that's when they decide whether they go disaggregated or hyperconverged.
I just make a quick comment on there is definitely growth in hyperconverged in it, but the bottom line is it's actually a relatively small market. At number one, number two, I think if really what's powerful about the cloud is ease of consumption. That it is, I don't have to buy any hardware. I can just use a credit card, and so I think there'll be kind of limits to where that will go. But anyway, that's just my opinion. Go ahead. Sorry.
So second question, I'm going to request that we not worry about technology for this question. So ignore whatever technology that your particular vendors are currently shipping. And let's think about this question from the point of view of an application. And the only thing that we're allowed to assume about the underlying technology is the number of microseconds or milliseconds of latency that the devices are producing. Okay, so ignore if it's flash or not. So I kind of see from my right to left, I'm seeing kind of different latencies, right? So we see tape here, maybe seconds, but and there's some use cases there, and then we see hundreds of milliseconds maybe for your new generation product that Gleb you talked about this morning. And then we're seeing flash, and then there is kind of between you guys, hopefully there is kind of this millisecond flash, and then there is the 10 microsecond and then 2 microsecond flash. So the question I have is for each of you, in those orders, what are the applications, again, worrying only about the latency that your technologies can deliver, what are the application areas that become enabled for your next generation of plans around those latencies and improvement of latencies that will disrupt the market? Okay, so let's start with seconds, hundreds of milliseconds, 1 millisecond maybe, and then 10 or 1 microsecond, right? What are the different applications?
Okay, I'm not going to ever promise microsecond access times on a tape. I mean, that is not on our roadmap. It is inherent in just the way data is laid down on the tape back and forth over a kilometer of tape. What we do focus on is make it easier to do random readbacks. We're putting new features in to make the drive smarter and so it knows where the data is on the tape to bring it back. But again, it's in the second realm, not in the microseconds. And we are focusing on being able to stream the data, whether you're writing it or reading it back, at faster and faster rates with each generation. And that's really where we're focusing. It's pretty much, it's not for when you're having to do real-time data analysis. It's not when you're generating your data. It's when you're wanting to go back and review something that has been done maybe 6 months ago, maybe a couple years ago, where time is not as critical and you can wait a little bit of time.
So it's an interesting question. I don't know that I have a great answer for you of what people would use it for. One of the things we were talking about yesterday was that in general, object storage in the cloud, you don't run a database on top of that. Right? That you would use something else as a backend storage for a database. There's nothing very inherent in object storage. If it was blisteringly fast, you could theoretically run a database on top of it. So we measured the latency from our office to our close data center. And it's about 6 milliseconds to pull a file. And so, we were talking about, could we install a database locally on one of our machines and just try and see what that experience looks like? So that's the kind of thing where I could imagine if we went down by an order of magnitude in latency, you might start being able to do some of those things, some analytics, analytical analyses that you might decide not to do on an object store. Those might be some of the types of applications.
So I'll go, and there's really two flavors, and again, we're in the same industry, probably have the same answer, but in the realm of non-volatile or persistent memory, that's actually a better term for it. There are several, even today, technologies, and what do you enable, right? So for really cold, dense flash, I would not run a relational database. I would not try to run real-time data analysis using Spark or something else. Not a great fit for that. But on the other hand, NAND is still fast enough for a lot of those applications to be processed quite effectively, right? Because again, tens or hundreds of microseconds of latency as opposed to milliseconds. So now we're climbing the order of magnitude cliff here. But yet then there are, again, persistent memory technologies, cross-point ReRAM, there's others in development that are now into the hundreds of nanoseconds. Right, so this, in some cases, now becomes not very good, but a substitute for DRAM, and has the characteristic of being persistent as well. And you can clearly see this in some of the processor roadmaps and the motherboard roadmaps. So enabling real-time analytics that quite literally could not have been performed before. And then again, to the point where we need to do a lot of work in the Linux stack and other block stacks, because now this material is fast enough that is literally faster than the kernel can interrupt and service and interrupt. So there's a lot of work to be done there to enable these applications to, for example, one very popular use case is fraud analysis, fraud transaction, right? So if you're a credit card company, put your chip in, some number of milliseconds pass. I actually live very close to one of the largest credit card companies in the world, and they have told me they have 220 milliseconds to process a transaction from a point-of-sale terminal. Back, including over the WAN and back, because if they don't, the point-of-sale terminal will say, yep, this is good, clear, right? And it could be completely bogus, right? So now how many transactions can you cram into that 220 milliseconds? This is a big problem for a bank, right? Or if you're doing high-frequency trading, you're one of the firms in downtown Chicago that literally microseconds matter because it's bucks, right? So those are the type of applications I think that persistent memory, certainly persistent memory enables, but, and people are finding this out. Again, the enterprise is no surprise here. They're doing SSD and HDD replacements specifically for these apps, whereas, back and forth to the cloud, the latencies are such, some number of milliseconds back and forth. That's the dominant factor anyway. So it really isn't efficient to have really, really fast media at the other end of that, because you're going to waste time sending, data across the air anyway. So
everything he says is applicable, as we're pretty much doing the same thing within certain time frames. The one thing that this conversation would be better served if we contained it with pricing. Because when you look at application being enabled, it really is being enabled at what price point to be able to deploy that at. And what you're going to see is when you look at Flash, even InfiniFlash, which is low-cost enterprise Flash, when you look at that capable of creating Ceph at 2 milliseconds, where does that hit? That hits the whole storage array market, the ones that are hybrid or disk-based. Because at the price point we announced last year, and assume a price drop of about less than $1 a gigabyte. When you look at that pricing going to the storage array market as a Ceph-enabled, i.e. OpenStack-enabled product, you're looking at something in the less than $2 range. But when you start putting Ceph with erasure coding on top of object, on top of file, on top of block, you're now at sub or at $1 per gigabyte without dedupe or compression. So 2 millisecond response time at $1 a gigabyte potential, that targets directly the storage array market and any application it deals with, which is databases, data warehousing, all those applications. So in a disaggregated model. And then the other aspect is putting persistent memory, putting flash for in-memory analytics. We see a lot of that today. We acquired Fusion IO, and that was their bread and butter. And when you see all the other areas that flash is being used for in just helping these applications that were bound by IO, that's pretty much, as the price drops and capacity increases, you're just going to see more and more of that.
One last question, then we'll wrap up.
That was a tape question. So the roadmap for the tape media looks quite good, but what's the roadmap on the actual drives that take advantage of this? So as far as, how much we're going to be able to fit on a tape.
So we do take that roadmap very, very seriously when we're doing our strategy. That roadmap was created with Oracle, IBM, all the LTO consortium, the media manufacturers. We all sat together and agreed to that. So there is a commitment on the tape industry's part to stick to that. And I can say, knowing Oracle's roadmap, we're going to be following that roadmap. And I know LTO has published their roadmap showing a healthy capacity increase. They don't put dates on it, but they certainly believe they can continue on this path as well.
So actually putting like 200 terabytes on a tape sometime within the next, what was the actual time frame for it? So
the roadmap was looking to do that by around 2025. You're going to, when we meet, like in 2020, we'll definitely be far above 20 terabytes. Now, how much further, I can't say at this point, but as I said, we know exactly what we have to do to keep on stepping each generation forward.
That's right. You can hear, if you want to hear more about, there's some vendor talks tonight, and including April, and including some of the other vendors who are presenting here. So again, with that, if there's any final thoughts from the panel, otherwise I will close, and let's thank our panel.